Lesson A2 notes, use properties of parallelograms. What is a parallelogram? Parallelogram is a quadrilateral that has two sets of parallel sides. So, here's an example of a parallelogram. One set of parallels, two sets of parallels. A quadrilateral with both sets of opposite sides parallel. Alright, now from this figure and with that definition we can come up with a number of properties that we'll denote with theorems. If we have this situation in parallelogram, we know that both sets of opposite sides will be congruent. Now what that leads to are problems like this A1 problem. Find the value of each variable in the parallelogram. Since it's a parallelogram, I know that this is congruent to that, and this is congruent to that. So x can set equal to 11, and we're done. Y can be set equal to 8, and we're done. Moving on to the next theorem. If a quadrilateral is a parallelogram, again, a parallelogram opposite angles will be congruent. And again, we go ahead and sketch a parallelogram. And we know these sides are congruent. We know that we would have a diagonal, and these two triangles would be congruent by side, side, side. Now with that, with corresponding parts, these will be congruent. And if I went ahead and I put this dotted in and got a left triangle and a right triangle, then these would correspond and be congruent. And that leads to a problem like A2. Again, since it's a parallelogram, we can simply say that these two guys, since they're opposite, these two expressions have to be congruent or equal. Divide by 4, and we get m equals 19. Now continuing, we have a couple more theorems here. And again here, theorem A5, if it's a parallelogram, consecutive angles will be supplements. This can be shown, again, by a parallelogram, by corresponding interior angles because of the parallels. If this was 80 degrees, this would have to be 100 degrees. These are CIAs, and they have to add up to 180. Now, opposite angles we know are congruent. So again, I can likewise put these guys in, and we can see that all the way around we get supplements. So, add to 180 degrees. That's what supplements mean. Now, an example here is A3. Again, since it's a parallelogram, I know that opposite angles are congruent. And then I know that these two have to add up, add to 180. So I can take 180 minus 36 for 44. And 44 will have to go here, and 44 will have to go here for angles. And then finally here, theorem 8-6. Now if we again have a parallelogram, if I go ahead here and draw this, and I draw the diagonals in, there's one diagonal, here's the other. we get bisecting diagonals. Now we can see they're not the same length, the diagonals, and we can see that they may or may not form a right angle, but we do know that they bisect each other, which means they split each other in half. So if this was 8, this would be 8. If this is 3, then this would be 3. That's an example of bisecting. So now A4 problem. Again, taking a look at these two are congruent because of the bisecting, because again it's a parallelogram. And this longer diagonal gets bisected as well. So that's 2y plus 9 equals 27. In each case, we have a couple of solve steps here. Subtract 9 on both sides. Divide both sides by 2. Make it that. Get y equals 2. We'll switch in here between the two. Subtract 6 on both sides. Divide both sides by 3. And we get x equals 2. This concludes the formal notes for 8-2.